Welcome back, everyone, to the Deep Dive, where we try to take these incredible ideas from thousands of years ago and see what they can teach us today.
Yeah, really just amazing how relevant some of these ancient ideas still are.
And recently, we've been really just captivated by the brilliance of this 5th century Indian mathematician and astronomer, Aryabhata,
Absolutely. And we've been diving deep into his masterpiece, the Daśagītikā.
a collection of 10 profound verses that really encapsulate his vision of the cosmos,
And last time we started exploring that vision by looking closely at verse 1.
which was like this beautiful invocation to the divine forces that shape the universe. Really sets the stage for everything that follows.
Yeah, it really does. And it's that everything that follows that we're going to dive into today.
And in particular, we're going to focus on verse 2, where Aryabhata unveils something truly remarkable, a numerical code.
Yeah, a code embedded within the Sanskrit alphabet itself, almost like a hidden language of numbers.
And some scholars have even called it an alphabet of the infinite, which, when you see how it works,
It's a very fitting name.
it really is, because it allowed Aryabhata to express these incredibly vast astronomical numbers using just the sounds of his language.
I imagine that trying to capture the scale of the cosmos without our modern mathematical notation.
Right, it's like trying to describe the ocean with just a few drops of water.
Exactly. And that's where the brilliance of Aryabhata's system really shines through.
It's like he had this deep intuition that language itself could hold the secrets of the universe.
And to really understand how it worked, we need to kind of step back in time for a moment and picture Aryabhata's world.
This is 5th century India, right in the heart of the Gupta Empire.
Yes, the Gupta period. It was a time of incredible intellectual flourishing.
There were these great centers of learning like Kusumapura, where Aryabhata lived and worked.
And this was a world where knowledge was primarily oral. It was passed down through speech and memorization.
So imagine trying to preserve these intricate astronomical calculations, these huge numbers, all through memory and recitation.
That's where the need for a concise and memorable system becomes absolutely essential.
And Aryabhata's code was just that. A remarkably efficient way to encode vast numbers into these neat little linguistic packages.
It's almost like he created a form of ancient data compression.
Exactly. And from an engineering perspective, it's just mind-blowing how elegant and effective it is.
And what's even more fascinating is that it wasn't just about efficiency.
There was this poetic dimension to it as well.
Yeah, it was like numbers as poetry.
Yeah.
Where he's weaving these mathematical concepts into the very fabric of language.
And that's where I think our modern co-pilot artificial intelligence really comes into play.
It allows us to analyze these ancient structures in ways that maybe weren't possible before, and to see the patterns and the underlying logic of this code.
So let's actually get into the mechanics of this system. How did Aryabhata turn letters into numbers?
Okay, so the foundation of the system lies in two main categories of Sanskrit consonants.
We have the varga letters and the avarga letters.
You got it.
All right, so let's start with the varga letters. What makes them special?
Well, the varga letters are these. They're organized into 5 groups, and each group begins with a specific consonant.
Okay, so there's a pattern there already.
Right, and within Aryabhata's system, specifically in the Daśagītikā, the consonants from ka to ma represent the numbers 1 through 25.
So it's like he's taking a portion of the alphabet and turning it into a built-in counting sequence.
Exactly. So ka is 1, ka is 2, ga is 3, and so on, all the way up to ma, which represents 25.
Okay, so that's the varga letters. Now, what about the avarga letters? How do they sit in?
All right, so the avarga letters are a little different. They follow the varga consonants, and they use a progression by tens.
By tens. Okay, so they represent larger numbers.
Exactly. So we have ya, which is 30, then ra, which is 40, la, which is 50, and this continues all the way to ha, which represents 100.
Wow, so we've got this system where the consonants themselves can represent a range of numbers from 1 all the way to 100.
Right, and so far it's pretty straightforward. But here's where things get really interesting, because then we bring in the vowels.
And that's where the real power of this code comes in, right?
It is the vowels act as multipliers. They're like these volume knobs that can amplify the values of the consonants.
So how does that work exactly?
Well, each of the 9 vowels in Sanskrit is assigned a specific power of 10. So, for example, the vowel A, which is kind of the default vowel in Sanskrit, represents 1.
Okay, that makes sense. It's like the base level.
But then we move on to I, which represents 100, then U, which is 10,000, and E, which jumps all the way up to 1,000,000.
1,000,000, wow. So just by changing the vowel, you can drastically increase the magnitude of the number.
Exactly. And this continues for all the vowels, with O, the last one, representing 10 to the power of 16.
Wow. That's a huge number. And I remember reading about Aryabhata's term khyughṛ.
Oh yes, khyughṛ. That's a fascinating term. It literally means 2 nines of zeros, which suggests that he was conceiving of numbers with up to 18 place values.
18 place values. That just gives you a sense of the incredible scale that his system could handle.
It wasn't just for small everyday numbers. This was a system designed to encompass the vastness of the cosmos.
So how do all these pieces fit together? How do you actually combine a consonant and a vowel to create a specific number?
All right, let's take an example. Let's say we have the syllable khyughṛ.
Okay, khyughṛ. So what does that break down to?
So khyughṛ starts with the consonant ka, which is a varga letter, and we know ka represents 2.
Right, because a ka is 1, ka is 2.
Exactly, and then we have the vowel u, which we know represents 10,000.
Right, and to get the final value, you multiply those two together.
Precisely so. 2 times 10,000 gives us 20,000. So that one syllable khyughṛ encodes the value of 20,000.
Wow, that's pretty remarkable.
It is, and it's really elegant.
It is, and it shows how you can pack a lot of information into just a single sound.
Absolutely. Let's try another example just to make sure we've got it.
Okay, how about an avarga example this time?
Sure, let's take the syllable ya.
Okay, yeah.
So ya is an avarga consonant representing 30.
And the vowel attached to it is just the inherent A.
Right, because there's no other vowel explicitly written, it takes on the default A sound, which we know represents 1.
So in this case, we would just multiply 30 by 1, which gives us 30.
Exactly. So ya simply represents 30.
Okay, I think I'm starting to get the hang of this.
Yeah, it's a pretty ingenious system, especially when you compare it to something like Roman numerals.
Oh my gosh, yeah, Roman numerals, trying to do any kind of complex calculation with those would be a nightmare.
Right, exactly. It would be a nightmare, whereas Aryabhata's system is so much more streamlined and efficient.
Yeah, and this really highlights how advanced Indian mathematics was at the time.
Absolutely. Aryabhata was way ahead of his time in many ways.
So now that we've kind of got a grasp of how the system works, let's see it in action with a real astronomical example.
Okay, I like it.
In verse 3, Aryabhata uses the term khyughṛ to represent the number of revolutions that the sun makes in a Mahayuga.
Yes, a Mahayuga. It's a vast cosmic cycle consisting of billions of years.
A mind-bogglingly long period of time. So let's break down khyughṛ and see how it encodes this massive number.
All right, sounds good.
So first up, we have khyughṛ, which we've already discussed.
Yeah, we figured out that khyughṛ represents 20,000.
Right, 2 times 10,000. Then we have u, which we also broke down earlier.
Right, u is 30 times 10,000, which gives us 300,000.
Okay, so we've got 20,000 plus 300,000 so far.
And then finally we have gu.
Okay, gu. Let's decipher that one.
All right, so gu starts with the consonant ga, which is the 4th consonant in its varga group.
So ga would be 4.
Right, and it's combined with the vowel, which we know represents a million.
So we have 4 times a million. That's 4 million right there.
Exactly, 4 million encoded in that single syllable.
It's really mind-blowing when you think about it.
It really is.
So to get the total number of sun revolutions, we just add up those 3 values, right?
Exactly. 20,000 plus 300,000 plus 4 million gives us a grand total of 4,320,000 revolutions of the sun in a Mahayuga.
Just incredible how much information is packed into those 3 syllables.
Yeah, and centuries later, the scholar Bhaskara, I actually referred to this number, this 4,320,000, as divine precision, which really speaks to the accuracy and the sophistication of Aryabhata's work.
And it makes you wonder where he got these numbers from.
Right. How did he arrive at these calculations?
It's like he was tapping into some ancient wisdom, some deep understanding of the cosmos.
Maybe. Yeah, maybe. And it's interesting to think about how this code was used in practice.
Right. It wasn't just a theoretical system.
Yeah.
It was a way to actually transmit and preserve this knowledge.
Exactly. And in an oral culture where memorization was key, a system like this would have been invaluable.
It's like he took these vast cosmic numbers and turned them into something that could be chanted and remembered, almost like a song.
Yeah, like a cosmic melody.
And it wasn't just about the numbers themselves. It was about the rhythms, the sounds, the way a language itself became a vehicle for encoding this knowledge.
Yeah, there's a real beauty to it.
Yeah.
But there's also this layer of complexity that we need to talk about.
Right, because verse 2 actually hints at the possibility of a second system.
Yeah, a second system that runs parallel to this multiplicative one we've been discussing.
So what's the clue that there might be another system at play?
Well, in verse 2, Aryabhata writes, Varga letters in Varga places. Avarga in avarga places.
Varga letters in Varga places, avarga in avarga places.
Yeah, it's a bit cryptic, but it suggests that the placement of the consonants might also have significance.
So maybe it's not just about the consonants and vowels themselves, but also about where they are in a sequence.
Exactly, and one way to understand this is through the analogy of a chessboard.
A chessboard, okay, how does that relate?
Well, imagine the squares on a chessboard alternating black and white.
Right, every other square is a different color.
And that's kind of how this second system might work. The varga places could be like the white squares, the odd-numbered positions in a sequence, and the avarga places would be like the black squares, the even-numbered positions.
Okay, I can see that, and then the Varga consonants would go in the Varga places, and the Avarga consonants in the Avarga places.
Right, so you would have this alternating pattern of consonants.
And the vowels in this system, what role would they play?
That's a good question. In this second system, the vowels might not act as direct multipliers in the same way they do in the first system.
So instead of multiplying, maybe they're acting more like place value markers.
Yeah, almost like the zeros in our modern decimal system.
So the vowel would tell you the magnitude of the number, and the consonant in that position would be the significant digit.
Precisely, it's a different way of structuring the information, a different kind of logic.
And why would Aryabhata have two different systems? That seems a little bit complicated, doesn't it?
It does, but remember, he was dealing with a wide range of astronomical data.
Right. Some numbers might be better suited to one system than the other.
Exactly, and some scholars have suggested that the number of the moon's revolutions, for instance, might fit more naturally into this place value system.
So he had these different tools in his toolkit, and he could choose the best one for the job.
Yeah, a versatile system for encoding different kinds of information.
And what's amazing is that AI analysis has actually helped to support these different interpretations.
Yeah, the AI has been able to show that the first multiplicative system works perfectly for khyughṛ, which is the sun's revolutions.
Right, but the AI has also hinted that this second place value system might be needed to decode other numbers in the Daśagītikā.
Exactly, and that's what makes this so exciting.
It's like we're still in the process of deciphering this ancient code.
Yeah, it's a 1,500-year-old puzzle that we're still trying to piece together.
So when we step back and think about the bigger picture, why does all of this matter? Why is this alphabet of the infinite so significant?
Well, on one level, it's just an incredible feat of intellectual ingenuity.
Right, to come up with a system like this in the 5th century is just mind-blowing.
But it's also significant because it tells us so much about how knowledge was preserved and transmitted in the ancient world.
Especially in an oral culture where memory was everything.
Exactly. Aryabhata's code allowed these complex astronomical calculations to be embedded within language itself, making them easier to remember and pass down through generations.
It's like turning data into poetry, making the cosmos sing.
It really is. And you can almost imagine these scholars chanting these syllables, these numbers, these cosmic melodies.
And it's no wonder that later scholars saw this system as divinely inspired.
Right, because it reflects this deep reverence for the universe that we saw in verse 1, the idea that knowledge and the cosmos are interconnected.
And for me personally, this deep dive has been fascinating. It's made me appreciate the power of language in a whole new way.
Yeah, it shows how language can be so much more than just communication. It can be a tool for encoding complex ideas, for preserving knowledge, for connecting with the universe.
And it makes me realize how much we still have to learn from these ancient systems of knowledge.
Absolutely. There's so much wisdom waiting to be rediscovered.
So Aryabhata's alphabet of the infinite is a brilliant example of ancient innovation, a testament to the power of human thought and creativity.
Yeah, it really is. And it's a reminder that even in the 5th century, people were grappling with these profound questions about the universe and finding ingenious ways to express their understanding.
And in our next deep dive, we're going to continue exploring the Daśagītikā and look at how Aryabhata encoded the movements of the moon and the earth.
Yeah, I'm really looking forward to that one.
Me too. And for our listeners out there, I encourage you to try playing around with Aryabhata's code yourselves. Take this syllable khyughṛ and see if you can break it down.
Yeah, it's like a little puzzle.
And once you unlock it, you can really start to appreciate the magic of this ancient system. So thanks for joining us on this deep dive.
And be sure to subscribe to the deep dive for more explorations of ancient wisdom and modern insights.
Until next time, this is Harsh Rain, signing off.